Today in this session, we are going to discuss about the Java collections framework. So first thing that what is collections in Java? The collections in Java is a framework that provides data structures to store and manipulate the group of objects. It means whenever you want to work on your group of objects in the Java, then collection framework provides you facilities for that. It also provides the way to perform different operations on that group of objects, like you can say searching, sorting, insertion, manipulation, and deletion. Java collection provides many interfaces like set, list, queue, dequeue, and also the classes like array list, vector, linked list, priority queue, has set, links has set, and you can say tree here. So this is the, you can say, main purpose of collection. Now, what is the hierarchy of collection framework? You can say this is the hierarchy, and your all the classes and interface in your collection frameworks actually you can say available in the Java util package. So this is the hierarchy. At the topmost hierarchy, we have a iterable interface, okay, and then we have a collection interface, and collection interface is again divided into the list, queue, and set. So this is the, you can say, complete hierarchy for the your collection framework. We will discuss everything, every interface and class one by one. First of all, we will discuss about the topmost interface, that is called iterable interface. The iterable interface is the root interface for all the collection classes. It means it is the topmost interface in your collection framework, and the collection interface extend the iterable interface. It means the second interface in your hierarchy. If we talk about the second interface in your hierarchy, that is your, can say, this collection. This collection framework is actually extending the iterable interface. Therefore, all the subclasses of collection interface also implement the iterable interface. It means if again see that all the classes, if you take the example of any classes which comes under the list queue set, like array list, linked list, vector, stack, priority queue, array, dequeue, tree, set, head set, these all classes actually you can say implement the iterable interface. And this iterable interface contains only one abstract method, that is called iterator, and it returns the iterator over the elements of type T. Type T means whatever collections you are using, and on the collections, if you are going to call the method iterator, it will return the object of a iterator, and this iterator will help you in, you can say, traversing or iterating the elements of your collection. Now, what is iterator interface? This iterator interface actually you can say contains three methods, and as I told you, the purpose of iterator is iterator method returns a instance of a iterator, and this iterator interface contains three methods so that you can iterate the every elements of your collection. So first method is, you can say, has next, and it returns the boolean. And what is the purpose of it? It returns true if the iterator has more elements, otherwise it returns false. It means whenever you want to iterate, whenever you want to traverse the elements in your collection, you can call this function, and if the answer, like you can use in the while loop, while has dots next, means till the time you have a elements, more elements in the collection, you can iterate it. Second is that object next function, and the return type is object. What is the purpose of it? It returns the elements and moves the cursor point to the next element. It means with the help of has next function, you can check whether you have more elements or not, but if you want to move to the next element, you have to call the function next here. And now the third function is called remove, and the purpose of remove is that it removes the last element written by the iterator, and this is very less used. Okay, so now this is all about the iterator interface. Now we will come to the, you can say, collection interface. Collection interface is the interface which is implemented by all the classes in the collection framework. All the classes, basically you can say that iterable interface is the at the topmost hierarchy, but you can say that the after iterable interface, collection interface is the backbone of the collection framework. All the classes you can say implemented by all the classes in the collection framework. In other words, we can say that collection interface builds the foundation on which the collection framework depends. So this is the importance of the collection framework. Now, collection framework has few methods, and these methods are, as I told you, because it is at the topmost hierarchy. So these methods are available to every interface and every classes. Like you can say we have an add method. It is used to insert an element in this collection. Then we have add all method. It is used to insert the specified collection element in the invoking collection. Then remove method. It is used to delete an element from the collection. Then we have remove all. It is used to delete all the elements of the specified collection from the invoking collection. Then we have a size method. It returns the total number of elements in the collection. Then we have connect contains, and it is used to search an element. If you want to search any element, you can call the contains method in your collection. And every but as I discussed, this is very important, iterator method, and it returns the iterator instance, and it returns an iterator means it returns you can say something like a cursor, so that you can use that cursor to iterate your whole collection. Then we have a to array method, and the return type is object array. And what it does, if you want to convert your collection into an array, you can convert with the help of this function. Then we have a is empty function. If you want to check whether your collection is empty or not, you can go with this is empty function. Now we have a equal method. Equal method is always, you can say, important everywhere. So in this collection, we have equal method whenever you want to match two collection, whether two collections are equal or not here. So now we are going to discuss about the first interface under the collection interface, that is called list interface. List interface is the child of the collection interface. List interface is the child of the collection interface. It represents a list type data structure in which we can store the ordered collection of object. It means list interface, actually you can say, implements the concept of list. And what is the quality of list? List is ordered. List is ordered, and it can have duplicate elements. So it means if the purpose of list interface is that it is going to present the list data structure, and in the list you can say the elements are ordered and it can have duplicate values. List interface is implemented by the classes like array list, linked list, vector, and step. So these are the classes which is going to implement it for the different purpose. So first class is going to which has implemented the list interface, that is called array list. Array list class implement the list interface, and it uses a dynamic array to store the duplicate elements of different data types. Actually you can say that array list behind the scene use the array concept, dynamic array concept. Okay, so now the array list class maintains the insertion order, and it is non-synchronized. It means, again, same thing is that it maintains the insertion order, it maintains the order, and it is non-synchronized, right? So the element is stored in the array list class can be randomly accessed. We can access it randomly. For that, we have different type of functions for that. So now if you take the example of array list, you can say that I have created in my Pradeep demo class, I created an object of a array list, and I added the elements like Lord Ganesha, Lord Shiva, Lord Ram, Lord Hanuman. And again, intentionally, I've added Lord Shiva 2 times, right? Because I want to show you that if you are going to use the array list, it allows you to duplicate and also maintains the order. It also maintains the order. So you can say that in the output, same in the order, I have inserted the element like Ganesha, Lord Shiva, Lord Rama, Hanumana, and Shiva. Same you can say in the output is coming in the same order. And it allows the duplicate. So you can see that Lord Shiva is appearing 2 times. So this is array list. Now, second, you can say type of list is that is called linked list. Linked list also you can say implement the collection. I told you that is the topmost hierarchy. So it implements the collection interface, as well as you can say it implements the list interface also. Okay, so now you can say it uses a doubly linked list internally to store the element. It can store the duplicate, because this is the feature of the you can say list, that it can store the duplicate element. So linked list also can store the duplicate elements also. But the benefit is that you can say that it is uses a doubly linked list internally. Okay, so doubly linked list means you can say that you can operate the linked list in any from any of the you can say site. It maintains the insertion order and non-synchronized. So that is also the quality of a list, that it maintains the insertion order and is non-synchronized. In linked list, the manipulation is fast because no shifting is required. As I told you, it maintains a doubly linked list. It means it actually just store the reference of the previous and the after nodes. So that's why you can say it is more fast in manipulation in comparison to the you can say array list, because there is no shifting is required. Okay, now if you take the example of linked list, you can say that same thing I have done that. Here I've created the class linked list class object and I added same thing. So same you can say output here you are able to see here. Now we are going to talk about the vector. Vector uses a dynamic array to store the elements, and you can say that it is similar to the array list. It is similar to the array list. Only the difference is that it is synchronized. Like you can see your your array list and linked list. They are non-synchronized, but you can say vector. It is you can say it is a type of flavor of array list, which is you can say only the difference is that it is synchronized and contains many methods that are not part of the collection framework. Okay, so you can say only the difference whenever somebody is going to ask the difference between the array list and vector. The main difference is that in array list, the method which are available in the array list, same methods are available in the vector, but vector is synchronized. So now if you take the example, I've created the object of vector, and you can say that again I added all the same data here, and you can say same, you can say order is maintained, and you can say duplicacy is also allowed. Only the thing is that it is synchronized. So whenever you want to use your collection in a multi-threaded environment, you should go with the vector here. Now we have a stack. A stack is a subclass of a vector. So if stack is a, you can say, subclass of vector, it is a special category. And why they have created? Because it implements the last in first out. It means it is called LIFO, last in first out data structure. It means whatever element we are going to insert, okay, that is going to add in the last, and whenever you are going to retrieve or fetch some element, it is going to you can say out the first one. Okay, first one it will be give you the stack contains all the methods of the vector class and also provides below method. So it means all the methods which are available in the vector, they are also available in the stack, because I told you stack is a subclass of vector. But other than that, it contains these three methods also. Like you can say first method is push, pushes an item onto the top of this stack. It means whenever you want to add any element on the top of your collection, then you can use the push method using your stack. This has exactly same effect add element item. Means whenever you add any item in your, you can say, collection, so same way it is going to add it, you can say, in the last. It is going to add it in the last. Same you can use the push method. So it is similar to, you can say, add element. Now second is that pop method. Removes the object at the top of the stack. As I told you, stack works as a last in and first out. First out means the which is available in the topmost, you can say, at the top of your collection, that is going to be retrieved first. So using pop method, it removes the object at the top of this stack and return that object as a value of this function. So it means if you want to remove your top element from the stack and also you want to retrieve that value, you can use the pop method. And again we have similar method like peek. Only the thing is that peek also does the same thing. Look at the object at the top of the stack without removing it from the stack. It means if you want to get the top element from your collection, your stack, but you don't want to remove it, so you can use with the peek. So difference between pop and peek is that pop removes the element, top element, and then return that value, and peek do not remove the stack, remove the top element from the stack, but it only returns. So this is stack. So if you see the example of stack, again see the same thing is, you can say that I've created the stack and it is adding the element in the same way. Now we are going to talk about the second important interface, that is called queue interface. Queue interface maintains the first in first out. We call it FIFO. FIFO means first in first out. Means whenever you are going to add anything, it is going to add in the top. It is going to add in the top, in the first one, not the last one. And whenever you are going to retrieve, it is also retrieve the topmost element. So that's why it is called first in first out order. It can be defined as an order list that is used to hold the element which are about to be processed. I told you why it is, because I told you it is going to use first in first out. Means whatever you have added first, it is going to out also at the time of reading, it will retain the first element. So that's why it is going to use where you have some priority things, right? So you want to process things very quickly. There are various classes like priority key, div queue, array queue, which implements the queue interface. Now, first we are going to learn about the priority queue. The priority queue class implements the queue interface. It holds the elements or objects which are to be processed by their priorities. Priority queue does not allow null values to be stored in the queue. It does not allow null values. It is very important thing. And now it has the methods. Some methods like you can say poll retrieves and remove the head of this queue or return null if it is empty. So what is the use of poll? Whenever you want to remove, whenever you want to, you can say retrieve the element, retrieve the, you can say, head of the queue, and also you want to remove that also, you can use the poll method. And if you can say, if the queue is empty, so it returns null. Now second method we have, that is called peek. Peek, again, peek is, the purpose of peek is same, similar to that one, like it does not remove the head of this queue, means it does not remove the top head element of the queue, or it returns null if the queue is empty. So it do not remove, only return. So that is the difference between the poll and peek. Now element retrieves but does not remove the head of the queue. This method differs from the peek only that it throws an exception if queue is empty. So only you can say the difference between the peek method and element is that peek returns the element, top head element, from the collection, and you can say if the queue is null, empty, it returns null. But in case of element, it also do the same thing, do not remove the element, retrieve the head of the queue. But if the element queue is empty, it throws an exception. Now we have priority queue example. Simply I have given same thing here. Now here you can say that here we have, you can say, learn this thing, like you can say, because it is uses the, you can say, FIFO. So you can say that I added Ganesha, Shiva, Rama, Shiva in this one, and you can say this is the output here. Okay, now we are going to learn about the DQ interface. DQ interface, you can say DQ interface extend the queue interface. In DQ we can remove and add the element from both sides. We can actually this is the queue which we can operate from both the side, like from the starting and from the end. DQ stands for a double-ended queue which enables us to perform the operations at both the ends here. So now the first, you can say, class we are going to which is going to implement the DQ interface, that is called array DQ. So array DQ class implement the DQ interface, and you can say that unlike queue, we can add or delete the elements from both the ends. Array DQ is faster than array list and stack, and has no capacity restrictions. Now this is the example of array DQ. You can say that I've added the element, okay, we're using the array DQ, and you can see the output here. Now we are going to learn about the set interface. Set interface extends the collection interface. It represents the unordered set of element. Unordered, it is very important thing. It represents the unordered set of element which does not allow to store the duplicate item. Means it is unordered. And second thing is that it does not allow to store the duplicate. We can store at most one null value, only one null value in the set. Set is implemented by hash set, linked hash set, and the tree set here. Now, first of all, we are going to learn about the hash set. Hash set class implements set interface. It represents the collection that uses a hash table for the storage. And hashing is used to store the element in a hash set. It contains unique items. So this is the example. You can create the object of a hash set, and then you can store the elements. I told you it is unordered, so you can say that it is not maintaining the order in the output here. Now we are going to learn about the linked hash set. Linked hash set class represents the linked list implementation of the set interface. It means linked hash set means it is using the linked list concept also, but in the with the combination of set interface. So it extends the hash set class and implement the set interface. Like hash set, it also contains unique element. An important thing is that it maintains the instance order and permits null elements. Now this is the example. We have added the elements here, and now you can see it is unordered. Now, sorted set interface. Sorted set is the alternative of the set interface that provides a total ordering on an element. Okay, sorted set is the alternative of set interface that provides a total ordering on an element. Like I told you, by default set do not maintains the order, but if you want to maintain the order also, then you can go with the sorted set interface. The element of the sorted set are arranged in the increasing ascending order. The sort set provides the additional method that in which the natural ordering of the elements. Now we have tree set. Tree set, Java tree set class implement the set interface that uses a tree of forest storage. Means it actually store the tree of a structure, like you can say one branch, two branch, again two branch, one branch. So it is something like a tree structure. Like hash set, tree set also contains unique element. However, the access and retrieval time of tree set is quite fast. The element in tree set shorted in the ascending order. So I think I think this is the, you can say, best example that in the tree set you can create the object, and now you can you can retrieve. So I told you this is a tree set, so it retrieval is little bit fast. So now this is all about the collection. Here I have just created this video just like a cheat sheet so that you can get the quickly understanding about the different type of collection. In my upcoming videos, I will cater every collection like array list, stack, everything you can say separately as a separate video, so you can get a proper understanding on that. If you like the video, can click on the like button and don't forget to subscribe my channel. Thank you.